Okay, so we've got an example here that's going to involve static equilibrium. So we've got a smooth bead Y threaded on a light and extensible string. The ends of the string are attached to two fixed points X and Z. The bead is held in equilibrium by a horizontal force of 8 newtons acting parallel to ZX, i.e. it's acting horizontally. The bead is vertically below X and the angle XYZ equals 30 as we've got shown in the diagram. We want to find the tension in the string and the weight of the bead. So we've got part of the diagram drawn already, but within that we also want to label some of the forces. So this triangle, this is really the string that's going through the bead. We're going to get tension in this string that's holding the bead up. So here and here. Those two tension forces will be equal to each other because the bead is smooth. And so that means we've got the same tension throughout the string. And the only other force that we're going to have acting is the weight of the bead, which I'm going to label as W here. So what we want to do is resolve forces horizontally and vertically, and then from there we're going to be able to solve to find T and W. So if we start by resolving horizontally, we need to break this tension force into horizontal and vertical components. So we've got triangle here, that angle and the angle there will both be equal, so that must be 30 degrees. So the vertical component is T sine 30 because it's opposite the 30, and this one's T cos 30 because it's adjacent to the 30. Okay, so when we resolve horizontally, the forces we're interested in will be T cos 30 and the 8 newtons there. So T cos 30 subtract 8 is equal to 0 because it's in equilibrium, everything's been held. So therefore cos 30 root 3 over 2 is then give us root 3 over 2t equals 8. So t equals 16 over root 3. And then perhaps want to get that as a decimal, which is 9.237604307 newtons, or about 9.24 newtons. So I want to use this number, the long one, when I'm working out more things later on. Okay, so we've resolved horizontally and found T, so that's good. We also want to resolve vertically. So the vertical forces are going to be T sine 30, and then subtract W because it's pointing downwards. So we've got T plus T sine 30 subtract W is equal to 0. Sine 30 is a half, so T add a half T is equal to W, or in other words, W is 3 over 2T. And because we've already worked out T earlier, we can now just substitute that in. And we're going to use the whole calculator display, which if you've not cleared it, is going to still be there, so we can just multiply by 3 over 2. Okay, so it comes out as being 8 root 3, so the calculator's remembered that, and then that's the same as 13.9 newtons if I'm going to do it to 3 significant figures.